Yesterday we talked about how to mark pictures so that we can write a proof. Today we're going to do more marking pictures, but we're also going to write the proof. Okay? So the class earlier told me change your Z right here to an A so that it matches mine. So this point A is Z on yours. Change it to A. Okay, so just like yesterday, we're going to look at first what's given. So we are given that XR bisects QY. So is QY a side or an angle? A side. So if it's being bisected, it's going to make two congruent sides. So if XR, think of XR as the knife, QY is the bread, QY is being cut in half, so that means that QA would be congruent to AY. Okay. Then we're going to label that angle Y is congruent to angle Q because that's given. So Y and Q are congruent. And then yesterday, once we labeled everything that was given, we looked at what was implied by the picture. So some implications from the picture. These are things that we can see in the picture, but they're not actually labeled. So things like reflexive property, vertical angle theorem, isosceles triangle theorem. So do you see any of those in this picture? We have vertical angles. Okay, if there is, anytime you have an angle across from each other, that is a mirror image, that is vertical angles. Okay? I refer to these triangles as like butterfly wings. If I made a little stick figure right here that had antennas, it would look like a weird butterfly, right? Anytime you have a weird butterfly, that is vertical angles. All right? So, if I was going to prove this, what would this triangle be like? Would it be side, 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 angle, 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 side, angle? And then this one would be angle, side, angle. So this is proved by angle, side, angle. So you basically wrote your whole proof in a picture. Now we're just going to write it in the chart. Okay? So what do you always write first in a proof? The given. So we're going to write XR bisects QY, and angle Y is congruent to angle Q, and we know that because it's given. We can also go ahead and write this prove in step 4 that angle YXA is congruent to triangle QRA. So change your X's on your sheet to an A, because remember we changed this to an A. Now, did we prove that these were congruent? How did we prove that? Angle, side, angle. So that's going to be here. Now I just have to go back and fill in my steps. Okay? So in the given, we have that something is implied here. When XR bisected QY, it told us that QA and AY were congruent. Okay? Since that's implied, we have to write it down. Okay? QA is congruent to AY. If it told me they were just congruent, it would be fine, and we wouldn't have to write it down. But since it didn't tell me specifically QA is congruent to AY, we have to write that piece of information down. Now, how did we determine it was congruent? Definition of bisect. All we did was write down the fact that this side is congruent to this side. Okay? Now, do you see how they tell us that angle Y is congruent to angle Q? Since it's very specific, angle Y is congruent to angle Q, nothing's implied. They tell me those two are equal. I don't have to write that step down. Yes? The X one would be XAY, yes, is congruent to QAR, because that's implied by the picture, but it's not stated. So I have to show that these vertical angles are congruent. So XAY is congruent to RAY, angle RAY, and that is because of vertical angle theorem. Yes, sorry, RAQ. Okay, so that time I labeled my whole picture first and then I wrote my proof. This next time we're going to do it step by step so you can kind of see the order. The way the order is going to go, and you can write this up here, you're always going to first write your given. Second step is going to be implied by the given. Your third step is going to be implied by the picture. And your fourth step is going to be your proof. It's always going to go in that order. Yes?
Are we going to try like paragraph proofs?
Okay, let's look at example 2. So in example 2, let's go ahead and write our given. So we're going to put X is the midpoint of YZ, and angle 1 is congruent to angle 2, and that's because it's given. Okay? Now, up here we have that X is the midpoint of YZ. So X is right here. Do y'all remember what the definition of midpoint means? It's a point in the middle of a segment, but it specifically does what to the segment? Cuts it in half. So that means that from X to Z and from Y to Z, those are congruent. Now, up here, does it say Y to X and X to Z is congruent? No. So since it doesn't say it up here, I have to write it. So Y to X is congruent to X to Z. And what definition did we use? Definition of midpoint. It tells you in the given. Definition of midpoint. Okay? Then it tells me that angle 1 is congruent to angle 2. Now, that's specifically stated, so we don't have to write that again. So, what is the third step that I told you before? Implied by the picture. So we're looking for reflexive, we're looking for vertical angles, for isosceles triangle theorem. There are verticals because you can treat these as butterfly wings, so that means that these are vertical. Okay, so I need to write down what that means. If they're vertical, the angles are what? Congruent. So I have to write that angle. And how come I just can't label this angle X right here? Okay, because there would be two angle X's and we would have no idea which one we're talking about. So you would have to label this BXZ. Could you do ZXB? Okay. Is congruent to AXY. Okay, and what's the reason behind that? That. Okay, and what is always our fourth step? The prove. So triangle XAY is congruent to triangle XBZ. Now, we didn't write down how this is. What would this be? Looking at triangle BXZ, what would the theorem be? Angle, angle, side. Very good. So this would be angle, angle, side. Was that a little better when we went back and forth?
Yes, actually.
Okay. It's okay. We have a few more. Okay, let's try number 3. So number 3 looks a little bit different from all the other ones that we've done so far. But we're going to treat it the same. So the very first thing we're going to do is write down our given, and that's that NO bisects angle RNY and angle ROY. And we know that because it's given. Okay? Now, let's label our pictures with the given. So the first one is NO bisects angle RNY. So if I'm bisecting an angle, I'm going to have two congruent what? No. If I have an angle and I'm bisecting an angle, I'm going to have two congruent angles. So the angle it's talking about is RNY, which is this whole angle right here. If we bisect it, we'd be talking about this angle, angle 1, and angle 2. So up here, does it say angle 1 is congruent to angle 2? No. So I'm going to put angle 1 is congruent to angle 2. And what's the definition for that? Definition of bisect. Okay. And the second part of the given tells me that it also bisects ROY. So ROY is this angle here, which means what two angles are equal? 3 and 4. Does it say up here 3 and 4 is congruent? So we have to write that. Angle 3 is congruent to angle 4. So did y'all notice this one has 5 steps? That's why, because the given implies 2 things instead of just 1 this time. Okay, now that we're done with the given, we've got to look at the picture and see if anything applies here. Reflexive property, okay? We see that triangle RNO and triangle YNO both share side NO, which means that it's congruent to itself, and the word that means congruent to itself is called reflexive. So I'd put that NO is congruent to ON, and that's because of reflexive property. And our very last step is just to prove. And so we're going to put triangle RON is congruent to triangle YON. Now, if I'm looking at RNO, how would we prove that these two are congruent? Angle, side, angle. Do you have the same angle, side, angle? Yes. So it would be angle, side, angle. My other class thought that this was easier than the last proof. So what do y'all think? Okay. Let's try another one like that. No. No. No.
No to my question or no to paragraph 13?
No. Yes. Okay, let's look at example 4. So we have never seen something stated like this. BT and RC bisect each other. Do y'all know what that means? Okay, this means that they are both bisectors then they're both being bisected. Okay, so let's go ahead and write that in my statement and reason for number 1, and then we'll show it in the picture. So BT and RC bisect each other, and then BR is congruent to CT. Okay, so if BT and RC bisect each other, that means that BT is being cut in half. So BA is congruent to AT. So I'm going to write that down. BA is congruent to AT, and that's by definition of bisect. Okay, and then also RC is being cut by BC, so that means this piece and this piece are being cut in half, or this whole piece is being cut in half, so these two are equal. So that means that RA is congruent to AC by definition of bisect. And then the last thing that's given is BR is congruent to CT. So this is BR. It's congruent to CT. Okay, so as you can see, we already have side, side, side. Do we need to look for something implied by the picture? We do not have to, since it's already proven. If you did, that's fine. You could prove it a different way. But since we already have side, 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 then we don't have to keep going. So we can go ahead and say that RAB is congruent to triangle CAT by side, side, side. Had we found that these angles were vertical, what's another way we could have proved they were congruent? Side angle side. Very good. Okay, I got one more for you, and then I'm going to let you try one. Let's look at 6. So in number 6, the very first thing we want to do is write our given. So HI bisects angle TIM, and IT is congruent to MI. And that's because it's given. Okay, so the first thing, HI bisects angle TIM. If this is an angle, then I'm going to have two congruent what? Angles. So if I'm looking at angle TIM, that's this angle down here. So that means this angle and this angle is congruent. Now, should I write that down? Yes, because it doesn't list what two angles are congruent. So I have to write angle TIH is congruent to angle MIH. And what's the reason for that? Definition of bisect. Okay. Then the second thing given is IT is congruent to MI. So IT is this side, MI is this side. Do I need to write down that? No, because it's just given to me. It tells me that they're congruent. So now, do I have enough to prove? No, so I've got to look at what's implied by the picture. What do y'all see that is implied by the picture? Reflexive property. Do y'all see that HI is shared in triangle HMI and also in HTI? That means that this is congruent to itself by reflexive property. So I would write HI is congruent to IH, and that's by reflexive property. Okay, and then our last thing is to prove. So triangle ITH is congruent to triangle IMH. What's the reason behind that? Side angle side.